Good morning, everyone. Thank you for attending, and welcome to Understanding the Evaluation of Microbiological Results for Proficiency Testing. I am Melissa Wright, and I am the ERA's Senior Account Manager for the Central U.S., Asia, and Latin America, and I will be your moderator today. Also, I would like to introduce your presenter, Mike Blades, ERA's Technical Manager for Organics and Microbiology. I'd like to start by giving a brief overview of ERA. ERA was founded in 1977. Our facility is located in Golden, Colorado. We work with more than 7,000 laboratories in more than 80 countries throughout the world. ERA also provides standards for several matrices: wastewater, drinking water, soils, air and emissions, microbiology, radiochemistry, and we provide custom standards. ERA is a TNI accredited PT provider, and we also carry all the necessary accreditations, including ISO 17043, ISO 17025, ISO Guide 34, and ISO 9001. At this time, I am going to pass off the duties to Mike Blades, and he will give you an overview of the agenda and get started on the presentation.
Good morning, everyone. Again, thank you for attending this webinar on understanding the evaluation of microbiological results for proficiency testing. Before I go over the agenda, I just wanted to make sure that I kind of reiterate what the target audience and the intent of this particular presentation is. Generally, we're targeting this towards participants that actually are in studies, QA officers that have to deal with the data, accreditors, pretty much anybody that's affected by the results on how microevaluations are done, and they want to learn more about that. So the intent is we want to give you an insight on how the PT providers are required by TNI to actually go through and arrive at the final evaluation. We will be covering questions, but those questions you can type in at any time in the questions box, but we're going to get to those at the end of the presentation. We do have quite a few participants, so I don't know that we'll be able to get to all of the questions, but those that we don't, I will try to answer, and we will post it on the website along with the webinar that you guys will have access to. So if I don't get to your question, I apologize. We'll do the best that we can. So for the agenda today, what we're going to do is initially I'm going to talk about just some basic considerations of quantitative microdata. It is pretty unique, and we need to kind of establish some background in order for the presentation to make sense. Then we'll get into the actual PT study data analysis requirements. Now, these are the TNI requirements that are put on all of the PT providers. They should all be following these rules when it comes to evaluation of their data for microbiology. So we'll get into data review. We'll get into the actual acceptance limit determination. We'll also do a slide on dealing with the effect of outliers, which is really kind of critical to this whole understanding of the evaluation of PT results. And then we'll actually talk about the evaluation rules that we have to follow. Then we will go into an example of an actual data set that really occurred, and we'll go through exactly how all of that played out, hopefully applying all of these rules that we talk about. And then I'll have kind of a rehash of the key points or the things that I would like you to take away from this presentation. And then at the end, we will make time for questions. When we do the questions, we'll bring Melissa back on, and she will probably kind of try to filter through the questions and read them out, and then I'll try to answer it so that I'm not trying to do both things at the same time. Should make things go a little bit smoother. So let's get started. I can. Okay. So why is microbiology different from other chemistry PTs? For those of you that have done a lot of microbiology, that may seem like a fairly silly question, but it is one that we need to discuss. If you think about it, it is the only TNI required PT sample that requires reporting and evaluation of quantitative results based on the actual growth of a bacteria. And you're doing that on a wide range of medias by a wide range of methods. Now, there are really only two basic approved techniques out there for the determination of the concentration for the commonly used indicator organisms. And what we're talking about here is coliforms, E. coli, enterococci, HPCs, and both the drinking water and the wastewater. The example that I'm going to give later is actually drinking water, but these rules apply to all of the micro. So those two basic techniques is one is a direct count. You're either going to do a membrane filtration or a pore plate or a spread plate. You're going to capture an individual organism, and then over a period of time on that particular selective media, you're going to grow something that is visible. You can count it with your eyes. The other way is essentially an estimation of concentration based on probability. It's not a direct measurement of the concentration that was in the sample. It's really a way to use probability theory to predict what that original concentration was. So you're not actually directly measuring it. You're just making a most probable number estimation of what that original concentration was. I'm on a new computer here, so bear with me. Okay. So some other reasons why it's different from regular chemistry. Many of the approved methods have significantly different levels of precision, and the precision is often not very good. So I don't say that to slight any micro method. I simply just point out something that is an obvious fact. There are a couple of methods, both of which we happen to be looking at in our example today. One is a standard methods method, 9221. It is a 15 tube test. You make a series of dilutions at 10, 1, and 0.1 mils. You do 5 reps. It's a method that a lot of you are probably fairly familiar with. If we were to have a sample that had, say, a theoretical value around 920 MPN per 100 mils, that test would give you theoretically a 553 positive result. According to the method, the 95% confidence interval associated with that result goes from 220 to 2600. Another common method out there that is a similar, or essentially the same technology, but they use a larger number of samples, is the IDEX quantitray. If you were to have a sample that were of similar concentration, in this example I grabbed 920.8 off of their table, that's a 49 large well and 37 small well, the 95% confidence interval associated with that is 620 to 1282. Now you can see these two methods are equivalent technology, at least as far as a lot of the folks out there that will evaluate this data, but the PT provider really can't look at it this way, even though these both may be part of the same data set pool. The other thing is results of bacterial culture methods often have a distribution of results that do not meet some of the basic assumptions for statistical evaluations. In most chemical analyses, the distribution of analytical results follow a normal distribution, meaning they're your typical bell shape or Gaussian curve where you have symmetrical results around the mean. This is not something that you will typically see from bacterial counts from culturing methods. Often what you have is a skewed distribution where you have many low results and a few high. It's referred to as positive skewness. anytime you're going to apply a statistical technique, it really assumes that the distribution of your results is symmetrical. If you don't have that, it's very hard to find a statistical technique that would be appropriate. So how do you get a normal data set so that you can evaluate it when it comes to microbiology? Well, the answer is essentially an approximately normal distribution can be obtained from a positively skewed microdata set by essentially converting every one of the data points to their logarithms. This type of a data set, if you convert it and it becomes more normalized, then it's referred to as being log normal. Now, T&I is specifically written into the FOPT tables that they require all of the providers to evaluate those results by first converting them to their logs. Now, I have here a couple of graphs, which I'm going to show you a few of these. And what you're looking at here is, people call it a distribution curve or a frequency curve, where we're taking a look at a data set. We're plotting the number of data points that occur across that data set. And then I'm plotting it on a graph so that you can see where points are most frequently reported. So if you look at the one on the left of your screen, where at the bottom you have CFU per 100 mils, that's an unlogged data set. So it's fairly normal initially, but then it has kind of this tail and hump that goes off on the backside. Now, if you were to calculate your statistics based around that, you're going to skew it towards the low side. So some of those folks that are in the tail of that potentially may fail. We know that we should expect this type of a data set from micro. So essentially what's happening on the right side is I've taken the same data set, I've logged all the numbers, and then I've plotted it again. Now you can see that the data set becomes a lot more normalized. It's not perfect, you can see some lift off there, but it's an improvement. So essentially that's what this T&I requirement is trying to accomplish. Now, let's move on to the data analysis portion of this. This is actually out of Volume 3, the 2011 of the T&I standard. It's out of Section 10.1. And this is under data review. So when a PT provider has a data set, the first thing that they're required, or one of the things that they're required to do, is they have to review the data set for what's referred to as bimodal or multimodal distribution, and or situations where you have disproportionately large failure rates by a specific method. So simply just gathering the numbers and calculating a limit are not acceptable. So the first thing we have to do, we have to look for that. Now the standard also says if bimodal distribution is found related to the analytical method and the acceptance criteria are calculated using a robust statistical analysis of the participant data, which this is true for micro, the results should be evaluated on a method-specific basis. Okay. The data review section also says that the PT provider shall review all PT study data sets for disproportionately high or low failure rates compared to historical norms. So not only do we have to look at what's happening in this particular data set, we have to go back and we have to look at what's happened in the past when we run these samples through the study, and is there anything out of the ordinary? So all of this stuff needs to be looked at, and that's defined by T&I. Doesn't matter who you're using as your PT provider, this should be consistent. Okay, so acceptance limit determination. And again, this is in section 10.2 of that same standard, the 2011. And that 2011, just for clarification, some people will refer to that as 2009 standard. It's the current T&I standard. It wasn't actually put into place until 2011. So maybe you'll sometimes hear people say that 2009 requirement. Actually, technically, I guess it's called the 2011 requirements. So we're required to calculate an acceptance limit as defined on the T&I FOPT tables. Now on the FOPT tables, the analytes are separated by the two technologies that I discussed, membrane filtration and most probable number techniques. The analytes, they have coliforms, E. coli, enterococci, and HPCs, are all handled as separate data sets. You can't mix and match either technologies or analytes, so obviously everything should be split out. Then the TNI table requires you to log transform them and either calculate the mean plus or minus 2 standard deviations. That's for drinking water, or the non-potable water, which is plus or minus 3 standard deviations. You do your final evaluation, and then you report information back to the participants as the anti-log of those evaluations. Analyte or study-specific evaluation criteria defined by TNI FOPT tables shall supersede the criteria stated in the section 10.2. The only reason I'm pointing that out is so that you understand that there is the TNI standard, which gives us all of these various rules, but it points out that a lot of it is driven by the FOPT tables, and the FOPT tables potentially could be changed at any time. You could have new analytes, you could have new concentration ranges, you could have new acceptance criteria, and they can change independent of the standard itself. So that's why I'm calling that out. The acceptance limits shall be represented following the same significant figure rules as defined for assigned values in section 6.4 of the standard. So essentially, values should be presented as whole numbers with no more than 3 sig figs. For acceptance limits calculated using the PT provider's assigned value, fixed or regression, the PT provider shall use their assigned value to calculate the acceptance limit defined in the TNI FOPT table. Now, assigned values shall be equal to the PT provider's verification and homogeneity testing for microbiology. This gets a little bit confusing because the standard is switched back and forth a couple of times and may so again in the future. You're going to be evaluated based on the mean of the study plus or minus the appropriate number of standard deviations. But we're, as a PT provider, still required to present an assigned value. With the current standard, that assigned value is not the same thing as the study mean. We're required to give you a value based on our verification and whatever methods we use, so it can get confusing. That was not the case for the 2003 standard. They used to use the study mean. The current voting draft that's out there looks like it's going to switch back to the study mean. This was a point of confusion for a lot of participants because they would see a mean that they were off of, but they were looking at our mean, the PT provider, and not the fellow participants. It got a little murky, so hopefully they're going to get that straightened out with the new standard. So acceptance limit calculating using the study mean and standard deviation, PT providers shall use the mean and standard deviation as calculated by the following procedures. Now again, everybody has to do the same thing, all the PT providers, and it's essentially segregated by the number of data points that you have. So if you have a data set where you have 20 or more values, you're required to calculate using the bi-weighted mean and the bi-weighted standard deviation. Now, the TNI standard has a section, and they refer to a particular paper that was published out there which gave you examples on how to perform that calculation. And it specifically tells you using 15 iterations with C equal to 4 and C0 equal to 6. It gets a little bit complicated. I didn't want to present the math. I just wanted to present that the standard specifically says when you've got over 20 data points, here's what you have to do. Now, for sample sizes where you have 7 to 20 data points, the standard tells you that you need to use the arithmetic mean and the standard deviation after an outlier test using the standard says a t-test, specifically an ASTM method, or other PTPA accepted outlier testing procedures. And you can't throw out any more than 20% of your data. That is, you can't treat those as outliers. So you have to kind of limit your ability to sort through the data, and you can't throw too much out. Now, when it comes to very small sample sizes, less than 7, values shall be evaluated using a statistical procedure approved by the PTPA. Now, this is where things might get a little bit sketchy, and what's being done by a PT provider could become quite unique. But be aware, that the N is what's really driving how things are being done. Now, the standard also has a statement in there about acceptance limits calculated using the actual study median. The PT provider shall use the median calculated for all properly reported data points as defined by the PT board in the data set. This really only applies, at least currently, to whole effluent toxicity testing. That's the only one that currently uses the median. Okay, so I wanted to talk really briefly here about outlier determination, since it really plays a big role in how that final limit gets determined. So outliers. Outliers are data points that are distant from the other observations in your data set. It's out there on its own, it's unique, it's different. What you're trying to do by looking for and potentially eliminating outliers is you want to limit the influence of that data point on your data set. So as we just discussed previously, T&I goes through and they define how do you want to deal with the outliers. So the best way to deal with outliers is something where we as a PT provider essentially don't have to establish what the outliers are. You do that by using a bi-weighted for handling those outliers, and that's when you have the greater than 20 data set. Essentially, that calculation will go through and it will assign a weight of importance to every data point, and it's based on how close is that data point to the center of the data set. This way, you aren't throwing out that outlier, you're just assigning a very low value of importance to it. So when it comes to calculating the limit, this person who maybe diluted their sample wrong, or they had very bad media, or it doesn't influence the overall data set. So really that's the best way to deal with outliers. It's very objective. I'm not picking who's going to be an outlier or not. I'm simply using a robust statistical technique to just give very low importance to those data points, and it's based on what's being reported. The next way you can determine the outliers is by running one of these outlier tests, t-tests, a Grubbs test, a Dixon, and you do that before you're obviously performing any of your calculations. You're going to do that when you have less than 20, but more than 7. The problem that you run into with micro on some of these outlier tests is all of these outlier tests assume that you have a very normal distributed data set. It really doesn't know what the distribution of your data set looks like. And sometimes in micro, since there is such an issue with the data set being skewed, after we blog transformed it, it improves it. But if you still have one of those slightly skewed data sets, these type of evaluations don't really care. It's going to throw the data out. So it's more subjective. And the other issue is, once you throw one data point out of your data set, you have to run the outlier test again to figure out whether or not you created another outlier from throwing out the last one. So it can get more subjective. Now, the worst case scenario is when you get down to data points that are less than 7. It becomes very difficult with micro, and the decisions that you make have a dramatic effect on whether or not you're going to evaluate somebody as acceptable or not acceptable. So that's what I wanted to cover with outliers, just to give you an idea of what this whole scheme is trying to accomplish through the T&I standard. Now, let's talk about the actual individual evaluation of results. T&I spells out in section 10.3 how to evaluate it. So if you have an assigned value that is greater than 0, the numerical value reported shall be evaluated acceptable if it's within the established acceptance limit, and evaluated not acceptable if the numeric value is reported outside the established acceptance limit, or the numerical value is reported with a less than sign and the numerical value is less than the lower acceptance limit. Now, this is a good way or a complicated way, or a very specific way, I guess I should say, of saying if you're within the limit, you're okay. If you're outside the limit, you're not okay. The other scenario is if the assigned value is set to the PTRL with a less than or set to 0, any numeric value reported with a less than, a reported value of 0, or a reported numeric value less than the PTRL shall be scored as acceptable. Not really specific to microbiology, since the analyte is always going to be present. So this is not something that really will come up in that scenario. And then something that is pretty relevant to microbiology is a reported value shall be evaluated as no evaluation if it cannot be evaluated. An example here would be, excuse me, an example here would be in microbiology, if you had a plate that you didn't dilute and it was overgrown and your method says, well, that's too numerous to count, that would be a no evaluation. So you need to keep that into consideration. You always want to be performing your dilution so that you're going to get a result that can be evaluated. Apologize, I need to take a drink of water here. Hold on. So if the PT provider, this is also stated in the standard, if we invalidate an analyte in a PT study, all the evaluation for the data reported shall be no evaluation. So, and you need to have a discussion of it, of what led to the invalidation, and it needs to be included in the final report to the labs and to the accrediting bodies. Essentially what this is saying is that we can't throw out a particular customer's data point essentially without throwing out all of it. So usually if we have a problem that we believe affected a given client, it's likely that either you're going to have to throw out everything. You're not just going to throw out a single data point. Okay. So the 2011 T&I standard makes no mention of evaluation of greater than results. Currently, it is left to the discretion of the individual provider. So the way ERA handles this, and to the best of my knowledge, currently a lot of the other providers do, is we will evaluate a greater than result as the associated value. So if you're running a quantitative or you're running an MPN, and for whatever reason you max out the test, maybe the lot that is being used is very high within the range. Say it's a wastewater and it goes up to 2,400, and you have something that is greater than 1,600, we're going to score that as 1,600. The current voting draft that is out there right now, they did add something in related to greater than values, and assuming if it passes and goes into place, any greater than results need to be evaluated as not acceptable. So keep an eye out for that. If it does go into place, obviously we'll call something out in our studies when that's first going into effect, since it's such a change. Okay, so now actually let's take a look at an actual data set. And I'll try to pick up the pace here to get through everything. So here's our scenario. We have a data set where we had 150 laboratories reporting results for total coliforms MPN for quantitative drinking water sample. It's what ERA calls their source water sample. Of that data set, essentially there were about 16, or not about, there were 16 participants that were reporting 9221B or some version of that, and reporting a result for total coliform MPN. And there were about 134 participants reporting 9223B or some version of that or descriptor of that using either ColAlert, ColAlert 18 or ColAssure. Sorry about that. I'm trying not to lose my voice here. They were using either like the 97 well or the 51 well. So we had kind of two distinct populations in our data set. When we did the initial evaluation of the data set, essentially we converted all of the data to their log. We calculated the bi-week by-weighted mean, and I've actually given you the by-weighted log numbers here, just so that you understand that we're dealing in log, and the by-weighted standard deviation. And we calculated, this was a drinking water sample, so we calculated 2 standard deviation limit. All right, so if you evaluate the data set with those calculations, essentially the mean, and these are the anti-logs, was at 57, and the acceptance interval was 26 to 126. The failure rate was 6.7, or 10 of the labs out of 150. Now, compared to historical, our failure rate was around 7.7. So this looks like a fairly good data set. You can see the plot on the bottom of the log data. It's fairly normal. Doesn't look too bad. But this is not all the PT provider is required to do. I told you in our scenario that essentially we had kind of two different populations of data where methods being reported. So we need to go into this a little bit different or deeper and ask ourselves the question, is this bimodal by method? Is the failure rate higher than expected? Well, at first blush, when you put everything together, you would say, yeah, everything's fine. But when you actually start to look at it, you can see that the failure rate that we were getting, out of those 10 participants, 8 of them were doing one of the methods, the 9221, and 2 of them were doing the quantitray. So I've got some frequency plots here of what I call quantitray, I'm calling multi-well, and the multiple tube, that's the 15-tube method. So I plotted those 2 data sets out differently, and they look a little bit funny because essentially one data set has 134 data points, and the other only has about 16. But if you overlay those 2 plots, you can see that they kind of have different modes, and they're spread out a little bit differently. So this is kind of a good indication that what we're dealing with here is just a bias related to the method, at least based on this data set. So, as I'd mentioned previously, the TNI standard tells you if multimodal distributions is found related to analytical method and acceptance criteria are calculated using a robust statistical analysis of the participants' data, results should be evaluated on a method-specific basis. Okay, so in this example, the multi-well methods are evaluated separately from the multiple tube methods because it appears that those results are based on bimodal distribution, and we're getting a disproportionately high failure rate by a specific method. So let's reconsider our evaluation. So once you split them out, and you take your 134 data points for the quantitray, and we go through and we convert everything to the log, we calculate our bi-weighted mean and bi-weighted standard deviations. We calculate the log acceptance limit. We evaluate the data. I've given you all of the anti-logs. The mean moves to 62.4, acceptance interval 36.9 to 106. You end up with a failure rate for this data set of 8.9. Not too far out of line with historical of 7.7, or you end up with 12 out of 134. We've got all of the folks that are doing these quantitray methods more segregated together, and the data set seems to be more appropriate when you look at it in that fashion. We take the 9221 participants, do the same thing, convert everything over to the log. In this case, since we're using the arithmetic mean, we do the outlier test. Essentially, this one determined that I believe there were no outliers, and we calculate the acceptance limit. The mean ends up being, the anti-log mean ends up being 33.2, and acceptance interval to 11.7 to 93.8. The failure rate is 1 out of those 15, which is about 6.2. So more consistent with the historical information and more of a equitable way of dealing with the data set. So I'd like to kind of rehash some of the key points here. All the PT providers are required to follow the TNI standard for PT study data analysis. It's not optional. All of the things that I discussed, really even the approach, you have to be looking at these points, and that should be consistent across all the providers. The other thing that is important because it's really the T&I scheme is the number of data points matter. The more data points, the more robust the evaluation. It's going to be more objective. The PT provider is going to have less of a say of, this is a good point, this is a bad point, here's what I'm going to do. You get less data, it becomes more subjective. I'm not trying to insinuate that anybody is going to do anything that discriminates against any one data point, but it's just the nature of the beast. The more data, the more you're assured that the data is going to be handled as fairly as possible. Data must be reviewed for bimodal distribution, and if it's found, the standard does have a should in there, but you can't really do anything but address the issue. If someone calls up and everybody doing 9221 is failing, you really need to have a very good reason, or the PT provider needs to have a very good reason as to why they did not address the issue. The other issue is you have to review it for the failure rate. And if you do see failure rates related to methods that gets out of line with your norm, it needs to be addressed. Those were really what I saw. You may have gotten other things out of the presentation, but those were kind of the key points that I wanted to stress. So at this point, I want to kind of open it up for questions, and we're going to get Melissa involved again. Bear with us here a second. We can get the questions box open so that we can both see it. And we'll see if we've got anything. So please feel free to type in any of your questions as soon as you feel like. So we'll start taking them as we get them. So let's roll on those.
All right. Thank you, Mike. Thank you for all that information. It was a great presentation. Looks like we have a couple questions. The first question is from Tim, and he's asking, how often do you see bimodal distributions by method or significant differences in failure rates? Mike?
Okay, I guess the example that I gave you, I wouldn't say it's not the norm. I gave you the example because it really showed applying the rules that T&I asked us to apply. We see this maybe 5 to 10% of all of the studies we run. We may see a situation where it appears to be bimodal and you have the necessary information to actually split the data set. Keep in mind, if you only had a couple of people reporting 9221, it's hard to make a case that that's bimodal unless you have the data set to support it. So more often than not, the various methods, you have more of an overlap and it's more difficult to tell the differences in the modes. So I would say maybe 1 out of every 10 studies, we may see a scenario like this on one of the microanalytes. Hopefully that answers your question.